Okay. All right. So, chapter 4 is probability. And probability is, have you ever got on a 2-lane road and got behind the old ladies club going 35 miles an hour and okay, that's enough, and get to the end of a road, into the road. Let's say y'all all know where Wild Hog Road is, right?
Yeah.
All right, you go on Wild Hog Road and you're going to Pendleton, and you get behind the little old ladies club, and they're going 35 miles an hour, and you get to the end. You can either go right and go toward Anderson, or you can go left and go toward Pendleton. And you got an 8 o'clock class, and it's about 5 or 6 minutes till 8 o'clock, and you're in a hurry, and you just passed Pendleton High School, and you're coming up on that red light, and you're going to get in the left lane. What is that little old lady going to do?
Get in the left lane.
She's going to get in the left lane. How'd you know? Can you tell the future?
That's just how slow people drive.
No, it ain't. It's called taking the past experiences you've had behind the little old ladies club and where you're going, and taking those two things and saying, okay, in the past, the person that's going so slow that's in front of me is going to go to the left. And you say that to yourself, and then that's what happens. Not that you manipulated that person to going left. It's just that you are taking the probability, you're taking past events. And what are you doing with those past events? You're taking the past events in your head, and you're saying, and you're assigning a prediction. I don't know how to spell assigning. I think it's 2 minutes. Assigning a prediction to the instant on Wild Hog Road. You're assigning a prediction based on what? Past events. Now, the difference in what we're going to be doing in probability is you're going to use past events, but you're also going to use statistics to predict something. Now, why am I so adamant, or I don't like to use the word prediction? All right? Because nobody can tell the future. And somebody usually says, oh, well, there's Chloe or Miss Chloe, or what was her name that got in trouble for fraudulent, Miss Cleo. Call 1-900 Miss Cleo, and she can tell you your future. What's wrong with that? Because if you could predict the future, would you be on TV at a 1-900 number? Where would you be? Wall Street. Where else? Where else would you be? Well, yeah, you'd be in the Bahamas after you went to Wall Street. But where in the United States would you go if you wanted to manipulate being able to see into the future? Wall Street is one. Lottery ticket. You'd be buying up lottery tickets. That's 2. What else? Place out west. Where is it? Vegas. Those are 3 places you'd be. And then, after you got through with a day or 2 at each one of those, you would go to the Bahamas. Okay? Why? Because if you could tell the future, you could hit every single one of those gambling, and the stock market is gambling, I hate to tell you, but it is. You would do it, and you would make money, and you would make so much money that you would just about bankrupt Wall Street, Vegas, and the lottery, because you would win every single time. But you'd have to be smart about it. Win every once in a while. Get somebody else to win for you. Okay? So, anytime somebody tells you that they can predict the future, all you got to do is give them a piece of paper and a pencil and say, what? What's the lottery ticket numbers? Oh, well, shut up and get out of my face, because you don't know what you're talking about. Nobody can tell the future. But what can we do? We can take past events and statistics, and we can assign a number to measure the probability of something happening. And that number is between 0 and what? 1. Between 0 and 1. Meaning it's going to be a decimal. Now, I'll give you another example of being able to tell the future. On the farm, we get up cows a lot. And we get up cows, meaning you vaccinate them, worm them, and all this other stuff. And let's say that there's a 10-acre pasture right here. And over here, there's a bigger pasture, let's say 50 acres over here. And in this 10-acre pasture, you've got a okay, I didn't mean that to happen. That's the wrong button. Let's see. There, and here. Okay, this right here we've got a gate that somebody has left open. And right here we've got basically a holding pen. That's where we there's a gate right there. In other words, we get the cows up right here to vaccinate them and all that good stuff. And then we've got a gate right here. You got the cows over in here, and you want them to go through this gate right here, come into this pasture, and then eventually you'll get them into this little holding pen. So you're getting the cows up, and you got 2 or 3 people getting the cows up, and they're coming this way, and they're coming this way. This gate's closed because somebody closed it. So they've got a possibility of going into this gate because it's open. That one's open. And this gate right here was left open. I'm standing up here at the back. I'm standing up here at the holding pen waiting for the cows to get up there because I'm going to close the gate. Which one do you think they're going to go to?
Down at the bottom.
They're going to go to that gate right there. Now, can they see that far? No. Cow can't see very far. Just the way probability falls. They could go right to here, no problem. Shorter amount of space, but they're not. They're going to go down here. They will go to wherever there's an open gate. All right? I just told the future. I'm going to go to Vegas. No, I'm taking past events of lifetime of growing up, getting up cows, and I know what's going to happen if there's a gate left open. They're going to find it. Now, is it the gate that I want them to go through? Heck no. But they're going to find this gate. That's another example. Now, what you're going to do is decide what probability is being used. There's 2 probabilities. There is the Mayberry probability, and this is the Hubertism. And then there is the physical probability. And yes, they're both Hubertisms. Why do I use the word Mayberry? Because I'm a Andy Griffith nut? Yeah, pretty much. But what is Mayberry based on? Mount Airy, North Carolina? No, that's not what I'm asking. What is Mayberry? Why do people like watching the Andy Griffith Show? People do like it. I hate to tell you that, but they do like it. They got 3, 4 trivia games. They got 3 or 4 trivia books. There is a cult following behind the Andy Griffith Show. Why? What makes it so entertaining? Okay, small town, you're getting there. It's a small town. The characters are likable, but why? People relate to it. Yeah, that's a good answer, but that's not what I'm looking for. I mean, think of other towns. It's what? It's perfect. Mayberry is perfect. It's a modern day what? Utopia. And people love that. Okay? Now the reason you can't get that with the Brady Bunch is 90% of the Brady Bunch happens where? In their house. Okay? You can't do it with the Addams Family because they just gross me out. Alright? You can't do it. Name another family. Not any of these modern sitcoms because these modern sitcoms are stupid. Yeah, like I said, stupid. Name another family show. Green Acres. Now people like Green Acres, but did it happen in a town or does it happen on a farm? 90% of that show happens on the farm. So people that don't like farms don't watch it, even though I liked it. Why? I didn't like it as much as Andy Griffith. But name another show that has, a family in it or a town. Can you name a show that takes place in a town? Not many. They tried to run a spinoff of Andy Griffith, and what was it called? Anybody know? Mayberry RFD. It lasted for about 6 months. If it ain't broke, don't fix it. And they tried. It didn't work. What does that have to do with this? Well, the Mayberry probability is kind of like the theoretical probability. It is the probability that's supposed to happen based on the numbers. All right, so you can write that down. I'm not going to write it down, but my definition changes every semester. All right, it is the theoretical probability based on the numbers. What do you mean, Hubert? What do you mean based on the numbers? Well, how many cards are there in a deck of cards?
54.
Actually, there's 54. Good. So you take the big mo and the little mo out, or you take the big joker out and the little joker out, and what do you got? 52. So 52 is a standard playing deck. So anything you do with the probability of that card is going to be based on what? 52 cards. That's the numbers. So what is the probability of picking a king? 4 out of what? 52. It's based on the numbers. Now, what is the physical probability? Well, you take a deck of cards and you shuffle them up real good and you pick a card. And it comes out to be 2 of diamonds. Is that the king? Nope. So you do it again. You do it 10, 15, 20 times and probability of picking a king. Somebody do this on your calculator. What is that? 1 over 13? So it's a 10. All right, somewhere around a 10. 0.1, somewhere around there. Probability of doing a king in the physical probability. This is actually taking a deck of cards and doing 10 shuffles and doing 10 deals with one card. And let's say you do 10 deals. And out of the 10 deals, how many times did you hit a king? 0. Then your physical probability is what? 0. What's wrong with this picture? They don't what?
They don't match.
They don't match. Well, dang it. Well, now you're into the world of probability. Why they don't match. They don't match because, one, it's very hard to get the physical probability to match. You might every once in a while get a number that's close, but to get it every single time is unobtainable. All right. Then how do you get the number close? Well, there's a theory in probability. It may be in your book somewhere. I don't know. They used to have a real nice article on it, but it's called the large number rule. So right now, you need to make sure you know what the 2 types of probabilities are, and you need to know what the large number rule is, because I've covered it, so that means it's important. And what is probability? And final rule of some more stuff. Oh, the scale, 0 to 1. You need to know that too. Large number rule says that the more times you try an experiment, the closer you're going to get to the Mayberry probability. Basically is what it says. The more times you try something, the physical probability will approach the what? Theoretical probability. So write it however you want to. There was a program designed by some college students, and there was an article in the 8th edition of this book. They were talking about the large number rule. And these two students programmed this computer program, or created this computer program, that they went in and took like 100 quarters. And they measured the quarters, they measured the weight, the density, all that good stuff, and they factored that into the programming, and they flipped it, and they counted the number of times with a slow motion camera they tried to flip it, or they fixed the little machine that flipped at the same poundage per square inch. In other words, the flips were what? Identical. Okay, it was done by a machine. So, and then they took all that information and they programmed it into the computer. So that, therefore, they could take a mathematical algorithm and predict what the probability of tails would be after 10 flips, 1,000 or 100 flips, 1,000 flips, 10,000 flips, and 100,000, and so on. What number do you think the physical probability was starting to match the Mayberry probability? Well, the Mayberry probability is point what? Point what? 5. Half. What? There's two sides to a quarter, right? Heads or tails. So 0.5, 1/2. Took 100,000 flips in that computer program to get to 0.49999945 something, something, something. Okay? Now, why do you have to think about the large number rule? Well, are you going to be at Michelin one day as an executive flipping quarters? No. But you will be asked to give what at the end of the year? A summary or a report. Now, if you're making $120,000 a year with Michelin as an executive, or whatever they pay, 6 figures, and you have a board meeting Monday morning at 8 o'clock, and you've had 6 months to prepare the meeting. Let's say you are the quality assurance director or executive at Michelin. Are you going to go out and pick 5 tires to look at? Or are you going to pick 5,000? 5,000 because of the large number rule. Okay? That's why they want to talk about the large number rule. So if you're going to put your neck on the line at a report at the end of the year, you better make sure you cover your what? Your backside. By using not 5 tires, but maybe 5,000. And that's why you use the large number rule. Okay? So let's do some basic theoretical probabilities. And the reason I do this is to show you how to come up with the probabilities, and to think, some of y'all might not know how many cards are in a deck of cards. Some of you don't know how many face cards are in a deck of cards. I know some of you invented the deck of cards, I know. But some people don't know what's in the deck of cards. Some people don't know what a die is. What is a die? It's a single cube out of the dice that you get for Monopoly. One of those cubes is called a die. Sometimes I have asked a question on a test, and the student came up, this was a hard copy test, long, long time ago, and the student came up to me and said, is this a graphical or typographical error? She thought it was supposed to be dice, and it said die. And what is the probability of a 6 on rolling the die? And she was like, I don't know what a die is. And I said, it's 1 cube of a die. It's half of a pair of dice. Oh. So you see, a lot of people assume things, but you know what assuming does? Yep. You don't want to do it too much. Especially if you're an executive with Michelin. You do not want to assume. because you'll get fired. All right, so I'm gonna see how many of you can do this. And again, I'm not doing it to insult your intelligence. I just want to make sure that everybody knows about a deck of cards before I give you a test. I want you to tell me what the probability of a face card would be. And if you don't know, just sit and meditate, because we're going to go over it. I want you to tell me what the probability of an even card would be. And an even card would be just a number that counts as even. And in this case, we're going to say that the ace is equal to 1. Okay? I'll put ace is equal to 1. I have to give you that information because the ace can mean what? What can the ace be? 1 or 11, Hubert. That's right, class. And let's go ahead and do the probability of rolling a 7 on a die. Now, in a lot of classes, that would be 3 basic questions. But I guarantee you somebody in here is going, in other words, what we're going to wear is going to be used in your sentence. Because not everybody plays cards all the time. Not everybody rolls a die all the time. So, you may have a question. Go ahead and find those 3 right quick. And if you can't, just consider yourself a disappointment and a failure.
Do you want the probability of an ace?
Probability of picking an even card. And they'll give me the cheese. Where are the plates? Y'all daggum took all the plates. Y'all suck. Walt, you still got a plate?
I didn't even get anything. You didn't let me get anything.
Okay, well now you can.
Yes.
You gonna call DSS while you're at it? Just use, nobody else is going to use it, just use the black thing. You didn't listen to a word I said. Did you see that? Walter, did you not hear a word I said? I said just use the black thing.
Oh well.
All right. Do you ever need to know how many things are in a deck of cards? I can always tell students this. Go Google Soldier's deck of cards. Anybody ever heard of that before? No, it's your parents' fault. Well, hello. Just Google Soldier's deck of cards. So if you're not familiar, and I know there's somebody in here, you don't have to raise your hand, but there's always one person in the class, 1 or 2 people, that have never touched a deck of cards before in their life. And dang old Soldier's deck of cards, dang old images. Dang old, where is it? Okay. Oh well. Maybe I'm looking it up wrong. Hold on. There it is, Soldier's Bible. Sorry. And you can Soldier's Bible. There it is. It's a song Bill Anderson sang it back in the 60s or 70s. I can't remember. I usually pull it up on images. Okay, I'll just quit. How about that? Let me just do web again. I don't want a video. What? GodTube? Well, I don't know what GodTube is. There it is. Okay, usually it comes with a picture and it tells you, and anyway, it's a little thing that was written a long time ago about a deck of cards. Anybody made the association with how many weeks are there in a year? Yeah, 13 weeks. How many? No, 52. 52, there's 52 decks. There's 52 cards in a deck of cards. There's 52 weeks in a year. That kind of a relation. Well, that's where Dangle comes from. Okay? So
they look at one a week.
huh?
They look at one a week.
No, it's just, if you remember all of this, you can remember a deck of cards. You can remember the numbers in a deck of cards. There's 4 suits, that kind of stuff. There's 13 tricks, blah, blah, blah. There's 13 in each suit. Huh? Yeah. Yeah, I didn't want to say that because somebody will say I'm trying to convert them, and I don't want the ACLU coming in here. So, but anyway, that's the way people remember the deck of cards. Anyway, so deck of cards, how many suits are there in a deck of cards? 4. So you got to remember that when you're doing the calculation of a face card, because you can't just go, oh, there's 4 face cards, 4 out of 52, or 3 face cards. You can't do that. You got to multiply the 3. There's the jack, the queen, and the what? And you multiply that by 4. Dang old 12. So the face card is 12 over what? And that's your answer. Now, would everybody know that? No. I guarantee you can go to Waters World and pull up, or go to Jaywalking and pull up deck of cards, and I guarantee you they went out and interviewed people about deck of cards, and I guarantee you somebody goes, I have no idea. How about an even card? Well, what I'd usually do here is I usually draw it out. Ace is what? 1. And then you got your 2. And your 3.
How is the ace and even?
And your 4. And your 5. And your 6. Can I be in charge for a while?
No.
7, 8, 9, 10, 11. Do we have 12? And then what? King, queen, and what? Jack. Is that all the cards? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Am I skipping one?
Yeah,
Oh, they're on.
there's 11.
See, I don't know my deck of cards.
Ain't no 11 either.
There ain't no 11.
No.
Oh, the face card. Okay, the ace is 11. I'm sorry. How's it 11? Well, I don't play cards that much. I play spades. That's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now we're back to Earth. All right, now let's go through and knock out the odd ones. So take my handy dandy red marker and we knock out the odds. And that. Because what is a king, queen, and a jack? It's 10. There's that, it's 10. So how many cards are even? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8. And 8 times 4 is over 52, which is 32 over 52. And nobody ever worries about 32 over 52. You reduce it down to what? 8 over 13. Somebody help me out.
Yeah, it's 8.
And that's, well, 6 out of 13 would be about a half. So you're probably talking about 0.65. Somebody help me out. What does it come out to be? Hurry up, Vanna.
0.615.
Oh my gosh. I was off by 400. 0.6 what?
15.
Okay, 6.2. So there is your probability about picking a face card. So would you bet $100 on it?
Yeah.
Yeah. You got a 62% chance of winning. Is Vegas gonna give you $100? That game don't exist. Why? Because of this. Okay? There's two entities in the world that are not into the charity business. One is the bank, and the other is Vegas. Okay? People say, oh, well, they give you all this stuff to go to Vegas. They pay for your room, they pay for your food. Yeah, because they want you to what? They want you to gamble, because they're going to get all that money back and then 3 or 4 times that much. What is the saying that I always tell y'all? Nothing is what?
Free.
Nothing's free. Now, why does this influence if this game is in Vegas or not? And Vegas would go what?
Bankrupt.
Bankrupt. So this probability for Vegas to have it should be what? Close to 0. That's what they want. They want the ones that are close to 0. Because that means they're getting the what? Money. What's the probability of rolling a 7 on a die? Good. Why? There is no 7 on a die. But people don't know that. Oh yeah, well, we're talking about 6-sided. Okay, I didn't specify. All right, I didn't know the octagon die or what. But anyway, on a regular die, that is 0. But see, I have put this on a test, and people have left it blank because they didn't know the answer. Okay. All right, so there is a few examples of what? Mayvariate probability or physical probability? Mayvariate probability. Theoretical probability. Because I have not shuffled a card, I have not rolled a die, I have not done anything. Now, if we bring a deck of cards in here, and I give each one of you a deck of cards, and I tell you to draw 10 times, and see if you get a face card or even card, then you would be doing a physical probability. See the difference? Yeah, I see the difference, Hubert. Thank you, class. Appreciate the interaction. Any questions on this?
No.
All right, now we're going to get into the roulette wheel. This is a test question.
The little thing where they turn the ball on it.
Yeah, throw the marble. Yep. Everybody ever seen The Gambler with Mark Wahlberg? You know I love movies. It's a good movie. It's a little bit weird for him. It's a little bit weird because he's usually a analytical type actor, but he's in the kind of a Michael Douglas character because it's just weird. Anyway, he's a professor that goes off on these rants, a professor of literature, I think, and he likes to gamble. The only problem with his gambling problem is that he'll win up to millions of dollars and then he'll gamble it all away and lose everything. Okay? Anyway, I don't want to give you the rest of the movie, but basically, in the movie, he talks about at the end of the movie there's a roulette wheel involved. Now, there's several ways that you can bet on a roulette wheel. If you don't know what a roulette wheel is, just dang old Google it. No, nobody should know. I mean, it's not one of those things that are commonly talked about at the family dinner table. But anyway, we'll just pull it up here. Dang old roulette wheel. I hope I spelled it right. ROULETTE wheel. Dang, oh, there's a roulette wheel. Right there. Now, all roulette wheels are the same as far as their initial makeup. You may have some that have 48 numbers. You may have some that has 32 numbers. I don't get into that. But the basic makeup is a double zero and a 0, and then a number of digits, and then black and red. And some people put green, that's fine. Some people don't. Okay, so there's dark green. All right. You throw the marble one way, you spin the wheel the other way. And where that marble falls is the winner. Now, there's two ways you can bet. What are the two ways? On the number or the color or both. All right? We're just going to go with the numbers right now because y'all know what the probability of the color would be, don't you? On a black and red wheel, it's what? 50-50. Okay, so that's Vegas ain't going to go with 50-50. So you're not going to win as much money on the color as you will. But if you have a lot of money and you wanted to bet it all, would you bet it on a color or a number?
Color.
Color, because you got a better chance of winning. You're just not going to win as much as you would if it fell on the number and the color or the number. Anyway, make a long story short, that's a roulette
Well,
wheel.
what, if you bet on a number, wouldn't it be like you're betting on the color too at the same time?
No, because
You could get a 22 and it's in the black.
yeah, you could. I mean, I don't know the official rules, but I do know that the probability of black and a number 26. Like if you bet on 26, you would be betting on black. But you can bet on black. You can bet on just the 26, just black, or you can bet on black 26. You don't know where it's going to fall. Black 26 is the lower probability, so therefore the stakes are what? Higher. Versus a black would be low. Okay? But anyway, let's say let me just pull up the problem that you're going to see on your test, and you're probably going to see 2 or 3 of these on your test. Why? Because this problem has everything in it. It has probability, it has the complement, and it has the odds against and the odds in favor. So that's why we're going to go over it, if I can find it. Hold on, let me find, there we go, 4.1, I think this is 4.2, study plan, and I'll find the problem. It's probably one of these. There it is. Vanna, blow it up so everybody can write it down. And you will see this on your test 2 or 3 times. And it's not going to change. You just have different numbers. So I don't want anybody saying that they don't know how to do it. There it is. We're going to walk through this one. It has several parts. I think it has 4 parts. But anyway, a modified roulette wheel has 32 slots. 1 slot is 0, the other is 00, and the others are numbered 1 through 30. You are placing a bet that the outcome is a what? Even number. Bless you. No more sneezing in class. Even number. Okay? Now, a lot of people are going to say, oh, even is going to be 15, the probability is 15 over 32. It's wrong, and you just lost the game. All right, you're going to have to think. I'm going to give y'all some time to write it down and give y'all a chance to do A, and then we'll do it. All right, then bring it down, please. Now, there's 2 or 3 things I want to talk about on this problem. The first thing I want to talk about is what is success in this problem? The success would be getting a what? Even number. Even number. So success in this would be getting the marble. I call it a marble, but it probably has some kind of fancy name. But getting the marble on an even number. That would be success. Now, what is the complement to success? Failure. And our failure would be the complement. Failure would be not getting an even number. Now, the reason I said not getting an even number is because somebody would have said odd. Can't say odd. Because 0 and double 0 are not negative or positive. So you can't just classify all the numbers into 2 categories when there's 3 categories. Alright? So, in this problem, the trick is to remember the second one. The second little thing. And that is the complement to success is failure. But the complement to even is not even. Let me give you an example. O.J. Simpson. Was he innocent? Or was he not guilty? We all know he was pretty much guilty, all right? But the court found him what? Not guilty. Why didn't they find him innocent? Why wasn't he innocent? Because innocent, he would never have been in the courtroom to begin with. Why? Because he had what? He had an alibi. He had visual proof. Let me give you an example. Mr. Bright works at Domino's Pizza on 24. And he goes to work, he takes his car to work, and he don't deliver pizza, he just makes the pizza. And his friend, his roommate, is Miss Long. And Miss Long needs to borrow a car because her car broke down and her father is sorry and won't fix it. And you can tell him I said that. And, no, I'm just kidding. And she needs a car, so she needs to go to work. And she goes and borrows his car. She gets a ride up to Domino's because they live right there near Domino's. And she borrows his car. But she didn't go to work. She went over to the People's Bank right across the road from Bilo, and she robbed that bank. And she killed 2 people while she was robbing that bank. Okay? And then she went and bought her a car with the money she stole and took his car back to him. And 2 or 3 days later, what happens to Mr. Bright? They come hunt him. Will Mr. Bright go to court? Why?
He was at Domino's.
Well, he was at Domino's. He has cameras at Domino's. And what is at the bank? Cameras. He's innocent. He will never go to court because he's innocent. Now, if he knocks out all the cameras at, I don't know why he would knock out all the cameras at Domino's, and I don't know why Mr. Bright would knock out the cameras at the bank, but if Miss Long knocked out the cameras at the bank, and of course, you know the places work, usually the cameras aren't on, but at Domino's, then it would just be his word and his boss's word and his eyewitness's word against, the bank. Then you would have to go through the process because it's just his word. And yes, there can be conspiracy, and yes, there can be coercion and people actually grouping up and teaming up on Miss Long or whatever the case may be. So there is 3 verdicts. There's innocent, which is acquittal. Then there is not guilty, which everybody is still thinking you're guilty, which is OJ. And then there is not guilty. Guilty, not guilty, and innocent. Innocent usually does not go into the courtroom because they can prove it before the arraignment. Okay? So don't always think of odd as the complement of even, because in this problem it just doesn't work. Third thing we're going to do after we find out these two things is we're going to find out the probability of success and the probability of failure. And then after the probability of success and after the probability of failure, you're going to find the odds. So those are the four things we're going to be doing in this problem. So, we know that the evens, probability of even, will be 15 over what?
32.
15 over 32. I'm making sure that the number is right. 15 over 32. The probability of not even is going to be 17 over what? Now remember, this is success, and this is what? Failure. So the probability of winning is 15 over 32, and that's what you do. Now, why do I not turn it into a decimal? Well, with the odds in favor and odds against, you're going to be multiplying or dividing a fraction by fraction, which means you're going to multiply by the what? And then you're going to the 32s are going to cancel. And it's a whole lot easier to do it that way than do it in your calculator. Okay? And then they're going to ask you what is the probability, or what are the odds against. They're going to ask you, and the odds against is the probability of failure over the probability of success. And the odds in favor, I don't know which ones they're going to ask you, is the probability is the reciprocal of this, probability of success over the probability of what? Failure. So the first thing I'm going to do is I'm going to type in the answer as 15 over 32. It's a miracle. What are the odds against winning? So I go back to my previous page, and the odds against is probability of failure. What's failure? 17 over 32. Over 15 over 32, and you multiply by the reciprocal, the 32s cancel, and it's 17 to what? 17 to 15. So you put a 17 here and a 15 here. Now before I go to the next problem or the next, I'm going to show you how to do that again because some of you are going, huh, what, where, huh? So let's go over that. Because remember, if you knew the material, you would. Wouldn't have to be here. Alright? Because if you knew the material, you wouldn't have to take a class. Okay? So, probability of failure is 17 over 32. Over 32? And the probability of success is 15 over 32. And that's odds against is the probability of failure over the probability of success. A fraction divided by another fraction, you multiply by the reciprocal, and the 32's cancel, and you're left with 17 over copying class, 17 over 15. And that is what the answer is. So if they were asking in favor, it would be 15 and 17. Now, the next question they're going to ask is, if you paid $10, if the payoff odds were 1 to 1, I don't like this question because it confuses students, but 1 to 1, if you bet $10, you're going to win $10, so you actually win nothing. So remember, C, you put the same bet money that you're betting. So when you get this on a test, If this is 20, that's 20. If this is 15, that's 15. If this is 100, that's 100. You just put in the same number because it's 1 to 1. I just think it's a waste of a test question. Okay? I don't really like C. So just remember, whatever this is, that's going to be there too. Now the next question, I disagree with the question because it actually uses, in my opinion, it uses bad English, but, and some of y'all gonna look at it and go, what are you talking about? Now just wait till I get there. So let's type in, what did I say, $10 here? It's a miracle. All right. Now, what if you bet $10 on your odds against winning? What if you bet the same $10 with these odds?
That makes me.
No, that's okay. Okay, you bet against, that's because that's what you're betting on. You're betting on the odds against winning. And a lot of people have no idea how to do this. Well, I'm going to go to I'm going to skip to a question here. Let's say I give you a recipe. I don't know how to spell recipe. For 24 cookies. Is that how you spell recipe?
Yes.
That's one of those words I never use. And then when I look at it, it looks what? It looks like recite. And I just don't look like recipe. I can't stand the word necessary. I hate the word necessary because I can never can spell it. I can spell Mississippi, but I can't spell necessary. So I just put need to have. I don't put necessary. All right, recipe. And it makes 24 cookies. 1 cup of sugar, 2 cups of milk, and 1 cup of flour. Okay, I know there's probably some chefs in here. Okay, and I know this is going to be a nasty cookie, but I don't care. I'm just giving you some things to multiply by, okay? So get over it and shut up. All right, 24 cookies. Now, I'm going to put a number up here, and people are going to say, okay, all you do is double it. Okay, that's not what I'm asking. All right, remember, if you knew the material, you wouldn't be here. 48. If I want to make 48 cookies, 48 divided by 24 is 2. So I multiply everything by what? 2. What if I wanted to make 72 cookies?
3.
Well, you divide 72 by 24 and you get what? 3. So I'm going to make, I've got 3 cups of sugar, 6 cups of milk, 3 cups of flour. Get it?
Mm-hmm.
What if I want to make 107 cookies? Somebody divide it by 24. What do you get? 4.5. So I'm going to multiply everything by what? 4.5. What are you doing? You're finding a constant to multiply by, right? So anytime you come up with a pour-over ratio, that's what Opie calls it on Andy Griffith. When you come up with a ratio, you just basically multiply whatever you need by that what? By that ratio. Now you can multiply by 48 over 24, or you can multiply by 2. You can multiply by 72 over 24, you can multiply by 3. This one don't come out to be real nice like this one does. But you're going to multiply by 4.5, or just multiply by the fraction. You with me?
Mm-hmm.
So what are you going to do here?
Multiply 17 over 32 by 15 over 32.
Good job. That's the whole point of me going through that, is so by the time you get back to the question, you can say, oh, I need to multiply 10 by 17 over 15. You would be surprised on how many students don't know to multiply that 10 by that 17 over 15. Now, take your 17 over 15. That comes out to be 1.2. Let me see if I can do it. That'd be 17, 15, be 20, basically 1.1. So 1.1 times 10 is 11. So it'd be about $11. What does it come out to be? 11.333. 11.33. So you put Well, you get 11.33. Now, where do I not like the problem? Where do I disagree with the problem? Look at the question. Anybody? I figure an English major would pick up on it just like that. Well, not that it's a grammatical error. I don't know if I said grammatical, but maybe I don't know. I just don't like the wording. What word do I not like? Huh? Profit. Why? Because the answer is $11.33.
But
You only made $1.33.
Exactly. You only made $1.33. You put $1.33, you get it wrong.
nuh-uh.
Bet me. Unless they fixed it.
You have to live in that first
That's why I disagree with it. All right. Now, let me tell you what they're thinking. As soon as you give up that $10, you have nothing in your what? Pocket. That's what they're, but I still don't agree with that. The word that they should use is payoff.
That money's
That's what they should be using. Payoff. What is the payoff? How much payoff should you make? Or profit, that is not the right word. Okay? Now they can disagree with me all they want to, the publishers can, but I detest this problem, not because of its content, but because of that word right there. I really disagree with that. Because most of us don't think of profit as, okay, I gave up $10, so now I have none in my pocket. They don't think of it. They think of how much did you pay and how much did you make. Subtract the two, and that's profit. So I made a big deal out of it, so you will remember it. Do not put the profit. Put the payoff. The payoff that the bank is going to be giving you after your big, gigantic win is what? $11.33. So you need to put that down right there. $11.33. Okay? So, first, probability. Second, odds against. Third, put the same number. Don't even do anything for C. Just put the same number. And then here, do not write the profit, put the payoff. So change this to payoff, or just remember to put the whole total. Okay? Give you one more so y'all can do that one right quick, and then we'll move on to something else. Dana, blow it up and hit freeze for me so I can take the roll. I need to take the roll for the last class too. I didn't do that. You froze it?
No, not yet.
Hurry up,
I'm
Dana.
gonna find it.
Bottom right hand corner.
I'm pressing it, I promise.
There, leave it alone.
Okay.
Okay, let me call the roll. I don't even know what time it is. What time is it? Oh yeah, we got time. I should finish chapter 4 by the end of the day, and y'all have a test tonight. I like that laugh. That was like, yeah, right, whatever. No, we should finish chapter 4 next week, so you're probably talking about a test next week. Only 3 or 4 sections we cover. Did I do this one?
That's not the exact same question. Do you?
Okay, we'll just forget it then.
Yeah.
I didn't know it was the same question. Let's see. Everybody was there this morning except for Vanna wasn't there. And Snyder wasn't there. And Young wasn't there. And let me do today's in this class. I put no class for y'all last week. I mean, what was it? Tuesday. I put no class. So nobody, hopefully y'all won't get a bureaucratic email. You should go to class. If you want to succeed, you should go to class.
I got one of those because it's a technical error in my online class.
Oh yeah, we have to keep up with attendance in our online
Because
class.
she had to give me an extension because it was like screwed up or whatever. And they sent me one and they were like,
Yeah, you missed a day in your online
Get your life
class.
straight.
Yeah, basically what it said. Remy's here, Mr. Bright's here, Mr. Brock's here, Miss Cowart's here, Miss Dyer is here, Miss Jones. Jones. Hello, Jones. Joshi's here, Long is here, Oriano's here, Putnam is here, Richardson is here. She switched seats on me, and Swinger is here. Okay, so only got one person missing. Okay. All right, so go ahead and hit the button again and freeze. Oh, do you unfreeze it? Oh, okay. And let's see what else we can find to discourage you as much as possible. Sometimes you might see one like this. Blow it up, Anna. To the right are outcomes that are possible when a couple has 3 children. You might want to write that down because you're going to see it again. The boy, 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 girl, boy, girl, boy. You don't have to write the word. Just say B, 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 G. That's the way it's usually written. So I thought you might want to write that down and put a highlight around it because you're going to see it again and you don't want to have to write those out again. Just refer to it in your notes. Okay? And find those probabilities. A, B, and C. I'm going to give you a minute to write it down and see if you can do it. And if you can't do it, just meditate. Did I turn that video camera on? Has it got a red dot at the top? Okay. That means it's recording. Good. I couldn't remember if I turned it on or not. I can't find my... Oh, there it is. Now, it's kind of, like I say, you might want to keep this because that's used in a lot of homework questions and a lot of test questions. It says, find among 3 children there is exactly 1 boy. 1. So you go over here and you find exactly 1 boy. So, ding, 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 here's 1. 1 boy. Ding, there's 1. And then another combination. So what is the probability of exactly 1 boy? 3 out of what? 8. This is called a sample space. All right, a sample space is when you actually draw out the endings to a outcome. Huh? You want to let me talk? Is it okay? All right. Now, what's another word for 0, girls?
All boys.
All boys. Duh. So, I think we can say all boys would be, oops, sorry. Dang old blue, dang old boy color. So that'd be 1 out of what? 1 out of 8. There are exactly 2 girls. So you take your handy dandy highlighter and you color it mauve. And you go
That's
2
the
girls.
same as number 3. I mean number
It may be, it may not be. Depends on how many numbers you got. But yeah, in this one it probably is going to be, but I don't know. So take your handy dandy mauve color 2 girls. Let's see. Ding, 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 ding. I'm looking for 2 girls. Here's one. Ding, ding. Where's another 2 girls? Ding, ding. And the next one. Ding, ding. So 3 out of 8. Now, a while ago you said, just a few seconds ago, you said it's going to be the same number as the other one. Well, because she was doing the complement. She was doing the complement of the complement of the complement. All boys and all what? Girls. That takes out 2 because it says that, what does it say right here? Exactly what? So that takes out, I'll just take my handy dandy red highlighter and I'll take those 2 right there out. I mean that one out and that one out because it says exactly 2. And then you've already got exactly what? 1, that took, I done lost it, but where did it take it out? 1 boy, at exactly 1 boy. Where's 1 boy? Right here? There it is. 1 boy, and 1 boy, and 1 boy. And what does that leave? 3 out of 8. Or you can count it like we did with the, pink one. You can count exactly 2 girls. Okay, I just did it backwards. You know what I mean. Oh, I'm sorry. I wrote it wrong. Exactly 1 boy is the opposite, so it's 3 over 8. Come out the same. Where is it? There it is. 3 out of 8. And that's it. So make sure you know how to find the physical probability, which we haven't done any physical probabilities, but it'll give you examples. If you shuffle a deck 3 times and you pick a face card 1 time, then that's 1 out of 3. What is the probability? I'm not going to spend a lot of time on that. But make sure you can make a sample space and make sure you can do the theoretical probability of whatever they throw at you. And that's 4.2. Okay? Capiche? Everybody feel good about themselves? Good. So that way I can pull the rug out from under you in 4.3. Now, 4.3 and 4.4. You're going to go in them together? Yeah, I'm going to go in them and teach both of them in one section. 4.2 is what is probability. 4.3 is the additive law. No. And 4.4 is the multiplicative law. Now those of you that have a book, you can turn to 4.3 and they'll give you some rules about the additive law and pretty much put you to sleep. But there's only one thing that I want to talk about with the additive law. If I can find 4.3. Eventually I will. How much? 149. Thank you. There we go. And that word right there, or. When you see the word or in your problem, it's going to ask you, that's basically the additive law. I'm trying to find the word. Somewhere in here it says or. I'm not going to sit here and look for it, but there it is. There's the word or right there. You see it right there. Anyway, somewhere in here they ask you, they specify the word or. But I'm not going to try to find it. But anyway, it's in there somewhere. All right. The word or, it'll say, what is the probability of this or this? And when you see the word or in those last few sentences or last few words of your problem, you know that you're going to be dealing with the additive law. If you see the word and, then you're going to be dealing with the what? Multiplicative law or multiplication rule. There is one problem with the one thing you need to watch for on the additive law, and that is always subtract the overlap. Overlap. How about the overlap? And this is a Hubertism rule. In other words, always subtract the overlap. When I get through showing you how to do the problem, you'll know what the overlap is. Okay? And those are the two basic rules for the additive law. And I'll show you an example and then you'll know how to do it. It's as simple as that. The multiplicative law, the word is and the only thing you have to remember about the multiplicative law is with replacement or what? Without replacement. Okay, so that's what you need to know for the two laws. So let's go look at an example. And the reason I'm not going into the definitions of the two laws is because all that will do is confuse you. Best to show you an example first, then tell you what it means. So, 4.3, dang old problems. Dang old try to find it. And I like to try to give you problems that are already in table form, like this one. You can write it down, Savannah, blow it up for them as they. Now, what I mean by table form, see the way this thing's represented? That's what I like to give y'all on a test. I like to give you a table, or where you can make it out like a table, because some of them are pretty simple, making them out. Don't try to start understanding the table. Don't try to read the table into it, because you don't need to. And if it ain't broke, don't fix it, and you're not trying to reinvent the wheel. All right, just do what I tell you. All right. Actually, all you need is just the table, and know that the total is what? The total of those four numbers is what? 1,000. Because that's going to be your denominator. 1,000 is going to be your denominator. I still see people writing, so that's why I'm waiting. Okay. Now, it says find the probability that, bring it down, Dana. Find the probability that the subject had a positive test result, ding, or a negative test result. So you take your handy dandy highlighter. Take your handy dandy highlighter. I'm going to use yellow. Negative test result. Boom. Because the column with negative test result is right here. Everybody see that? And positive test result. Well, that'll be this. Thought I hit green. Positive test result. I didn't love this question. I wanted an overlap question. It's not giving me an overlap. Okay. That's all right. We'll do it. So, it's actually not supposed to do this.
Can you have 1,000 over 1,000?
Yeah, it's going to be 1,000 over 1,000. It's not supposed to do
That's
that.
1.
Yeah, so the probability is 1. I picked a stupid question. All right, anyway, the probability of a positive test result or a negative test result. So, do I have an overlap? No, so I don't have to subtract anything. So what you do is the probability of positive plus the probability of negative over n, which is what? 1,000. And that's basically what the OR means, is you add the two probabilities up. This is not a test question. It's not one I would give you on a test. I thought it was one that I was going to have an overlap in. So what is the probability of positive? Well, 72 plus 85 is 157. No hiccuping, please. No coughing, please. All you can do is breathe. 837 plus 6 is 843. And if you add those two together, you get what? 1,000 over 1,000, which is 1. So very likely probability. Because you're picking both categories. This is not the problem I wanted to pick out. But anyway, it's a simple one, but you're not going to see that on the test. All right? Let's see if I can find one that's a little bit better than that with the overlap. Hopefully the next one will have an overlap. Hello? All right. Following, blah, blah, blah. If one pedestrian, what is the probability the pedestrian was intoxicated or the driver was intoxicated? All right? You know, that'd be a mess if the driver and the pedestrian was intoxicated. I don't think they could hit each other, could they? Because the driver would be like this and the person would be like this. Not no fun. They're already dead. We don't know who they are. If we knew who they were, it'd be different, you know. All right.
So basically, they can't both be intoxicated.
Yeah, they can.
No, but that's not asking for
He's saying, what is, if you put, let's say that every one of these 63, 98, we put a name on a piece of paper
Then that's the
and we
exact same
put
question.
if they were intoxicated or not.
Then that's the exact same question as the other one.
No, it's not. This one's different. Because the pedestrian, he said, the pedestrian was intoxicated. That's this one. Pedestrian intoxicated. And the driver was what?
Okay.
That's those two. And there is a what? An overlap. And that's ones you got. That's the ones you're gonna have on the test.
So the answer would be 63.
No.
Or the all of that.
You gotta do everything out. Let me do it for you. We know that the denominator is gonna be what? 998. Yeah, 998. So probability of intoxicated pedestrian or intoxicated driver. That means you put all the drivers' names and all the pedestrians' names in a hat, and on each slip of paper you put if they were intoxicated or not. And they want to know if you pick one person out of that hat, they want to know what is the probability of it being a intoxicated driver or intoxicated pedestrian. They want to know what the probability is that slip of paper has intoxicated on it. That's what it's asking. And that's going to be equal to 63 plus 98. That's dang over 161. Y'all check me? I'll better write everything
I don't
out.
know. I think she said it.
So 63 plus 98, and that's not the way I do things. Usually what I do is I take this color, hold on just a second. I usually do this. No, takes the whole thing. Oh, just forget it. There. All right. I usually take the green, and I'll do this, and I'll take the yellow, and I do this. There we go. And then I highlight this, 63. Did something change? Oh, I was fixing to write 98. 98. And that is my green, my yellow. It's right here. And I'll put that in parentheses because that represents the yellow strip going across here. plus, and then I'm gonna do the green strip, which would be 63 plus 270. So I take 63 plus 270 and move it over out of the way. And it's not going to cooperate. I don't think so. Sometimes I really don't like this whiteboard. There's that. That's those two numbers right there. And then with the additive law, you always subtract the overlap. And the overlap, take our handy dandy highlighter and change it to an orange color. Overlap is right there, which you can't see it now, but it's 63. Because that's where the two colors what? Overlap. And you subtract that out. And I always get one student that says, why don't you just cancel it out? Okay? What is my job as a teacher? Is my job as a teacher to teach you the simplest way to do something or teach you how to do something?
How to do it.
I teach you how to do it. All right? I'm assuming that you don't know how to do it when you walk in the door. Okay? So, in other words, shut up. All right, minus the overlap, which is what? And all that is over 990. That is how you do an additive problem. Bare basics. You always subtract the overlap, and we'll color this overlap orange. So the probability of IP or ID is equal to, that is 161 plus, that is what, 333, somebody help me out, minus 63 over 998. That's 63 would be a whole lot easier to take away from 333 than it would be to take away from 61. But you could, if you wanted to, take away the 63 from the 161. But I'm going to take it away from this guy because it'd be a whole lot easier, right? Be like 270 or something like that. Hmm? Yeah, 270, so that takes that down to 7. However you want to do it. Try not to do it on the calculator because this is just math. You shouldn't be doing basic math on the calculator. So anyway, 270 plus 160,
431.
so it'd be 430 plus the 1, 431 over 998. 431 over 998. Now, in your head, because you don't want to depend on a calculator your whole life, you know that 862 would be 0.5, right? 862 would be 0.5, so this one's digging into that one more or less. 862 is half, so that one's digging into it more, so it's going to be what? Around 0.4 or something? What does it come out to be? 0.431. 0.431, which is 43% chance, or 0.43 probability. So you got a 43% chance. So if you were a betting person, you'd probably win. You know, it's a little bit less than half, but it's better than 0. And that would be the probability. Type 3 decimal places. I hope you told me right. 0.431. I hope you don't set me up. I thought it was 1,000 right here. I mean, this is 998, is it not?
So it would be slightly off.
No, it's 4.
Yeah, 998 is not that big a difference between 1,000. So it probably is like,
It keeps going.
yeah, 0.43111. So it's not going to be that much of a difference. Okay, so that's come out to be 0.431. I can't get it to work. There we go. 0.431.
For that, it's 0.432 because you round.
Okay, whatever you say. If you set me up, that means you failed the class. All right. I'll wait till the next question you get wrong, then you fail. All right. So the biggest thing you have to learn here is to subtract the overlap. What if you have two columns and you don't subtract, you don't have an overlap? You just don't subtract it. You don't reinvent the wheel. Okay? Now, one question that I really like, and that usually is on my test, is the blood type question. What blood type are you, or blah, 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 and it's got O, AB, and all this other stuff, and it's got positive, RH and negative, and RH positive. If you see that one in your homework, put a star beside it, because I usually can't find it. And y'all, that time, y'all need to go, because it's about, what time's class over, 2:20 or 2:30?
I mean, 2:30.
2:30, okay. Well, we got time to get into our multiplicative. And I just want to get into the multiplicative just because, no, let's wait and do it Tuesday. Y'all get out of here. Have a good day. Somebody hit my button for me.
Thanks for the chicken fingers.
Yes, ma'am. Thanks for not fussing too much the other day when I couldn't make it to class.